Okay, this is geometry and we're on test 10. So let's go over these. So number 1 says true or false. These first 5 questions here are going to be true or false. And they take some figuring out, let's tell you, because you can't just guess and think, oh, that sounds, I'll just guess, because you'll guess wrong, just telling you. So all of these are in the answers we can look up in your book. Some of them I'll put the pages that you'd have to look and I will look at it. So number 1, if 2 rectangles have equal perimeters, they must have equal areas. You know that's false. Take an example. Here we have the perimeter of this rectangle is 30, and the perimeter of this rectangle is 30, because it's 10 plus 10 plus 10 is 30, so that perimeter is 30. This perimeter, though, is 13 plus 13 plus 4, so 13 plus 13 is 26 plus 4, and this is 30. Now, if we look here and find the area, of course, is base times height equal area on a rectangle, right? So if we take the base times the height, we take 13 times 2 is 26, and 5 times 10 is 50. 26 doesn't equal 50. Right there, put almost anything in there and you'll get no, 2 rectangles having equal perimeters, they do not necessarily have equal areas. So this has to be false. So a good way is just to give yourself an example. That's what I do. So number 2, 2 equilateral triangles now having equal perimeters now have equal areas. So now we have triangles. So if we have 2 triangles that have equal perimeters, they have to be equilateral. That means each one of these have to be the same. So 2 times 2, 2, 2, 2. There's no other way we can make with that. If they're equilateral and we divide them out, they all have to be the same number. Well, if you have 2, 2, 2, there have to be 2, 2, 2 on this one. So, this one has to be true. You can't make an example on this one. So, number 3, the diagonals of a parallelogram will divide it into 4 equal triangles. So this is kind of an old one. We had this before. So if we divide the diagonals of it, so we'll have a triangle here, 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 and it will divide us into 4 equal triangles. True, true. So get true down. Number 4. So this one, I have a page number down because we're gonna have to look this one up, or memorize it. So number 4 says, the line joining the midpoints of the bases of a trapezoid forms 2 similar trapezoids. So go back to our trapezoids. And so what does it say on page 250, number 4? I have these hidden ones, don't they? Gives us something here. Number 4, 250. It says, the line joining the midpoints of the bases of a trapezoid divides the trapezoid into 2 equal parts. Equal parts. So the midpoints of the bases, they have it written here, divides it into 2 equal parts. So this is a kind of a tricky one. So I put tricky one on it because I got it wrong, I think. So because I thought, oh yeah, it does, but it says the line joining the midpoints of the bases of a trapezoid divides the trapezoid into 2 equal parts or areas. And they say 2 similar trapezoids. Those 2 things are different. These trapezoids aren't similar. When you divide it here, they're not really similar. That means they don't look exactly alike, but they have the same area. So this is a tricky one. It would be false because instead of similar, you'd have to put 2 equal parts or areas. So they put that in instead as similar just to get you confused. But it's a tricky one. So if you read it real fast, you'll probably get it wrong. You might have got it wrong probably. So number 5. Number 5 says, a line segment which joins the midpoints of 2 sides of a triangle forms a triangle that is 1/4 the area of the original triangle. So on page 251, number 4. So we can sit here and try to figure this out. Is it going to be 1/4? Let's find out. Let's turn to 251. Number 4. another hidden one they got there. It says, there we go. A line joining the midpoints of two sides of a triangle, that's what they told us about, cuts off a triangle whose ratio to the original triangle is 1 to 4. It looks like it's 1 to 2, but it's 1 to 4. So let's see. See what the question was? A line segment which joins the midpoints of the sides of a triangle forms a triangle that is 1/4 the area of the original triangle. 1 to 4, right? That's what it told us there. The line joining the midpoints of two sides of a triangle cuts off a triangle is 1 to 4. So it's 1/4. 1 to 4 equals 1/4. So true. Okay, now we go on to the other questions that are not true, false right now. So in fact, they're multiple choice. So number 6 says, a medium of a triangle that divides it into two triangles which are always what? So a medium, let's look, draw a medium. Basically, a medium is an angle. It means this angle is the same and this angle is the same, and it divides it down here, okay? So they want to know, is it congruent? Think what section we're talking about too. We're not talking about anything in this section about congruency. B, is it similar? Well, we haven't been talking about similar triangles in this section, have we? Is it equal in area? Yes, we've been talking about areas. So most likely it's going to be equal in area. Well, to find this out, is it equal in area? Well, area equals 1/2 base times height. So we know if this angle is the same as this angle, then this is equal to this one. So it's going to be 1/2, and this line is going to be 1/2 base times height. So they're going to be equal in area. Works out. Both these sides are going to be equal in area. So equal in area. All right. And just whenever you study something and they bring out something that's not even in the text, it's probably wrong with a multiple choice. So we didn't talk about congruence here. We didn't talk about similarities, but we've been talking about areas, right? So then we think it's probably this one, Okay, but it could be this one. Okay, could be none. But anyway, the next is number 7. If each of the dimensions of a rectangle is multiplied by 3, the area is then multiplied by what? You think, okay, well, let's do an example of this. Just think, when you're doing a test, do an example. Each dimension, we have a rectangle. So we have a rectangle here, and say its area is 9, which is 3 times 3. So that's really a square, but a square is a rectangle. So 3 times 3 is 9, so the area would be 9. So now if we multiply each of these sides by 3, we'll have 9 times 9. Well, what's 9 times 9? 9 times 9 equals 81, right? And so now we multiplied by 3. What did the area multiply by? Well, 9 times what equal 81? 9. 9 times 9 equal 81. So it will be multiplied by what? So each dimension of a rectangle, if you multiply by 3, then you're going to have to multiply the area by 9, right? Kind of important, because even if you were trying to figure this out, when you're trying to figure something out and you decide that you're multiplying each one of these sides, you're going to have to not multiply by 3. The area is going to multiply by 9 instead of 3. 3 times 3. So anyway, because 9 times 9 equal 81. So 9. This is one that probably a lot of painters and, when you're trying to figure out areas and you multiply each side, you have to multiply that by the number, by 3 times 3. So 3 times, by times the number instead of, it's not going to be just adding it to 81 or adding this number. You're going to have to multiply it out. So number 8. Number 8. If the lengths of two adjacent sides of a triangle remain constant and the degree measure of the included angle increases from 1 to 90 degrees, then the area of the triangle is A, increases, B, decreases, remains the same, C, or none. Okay? So just think, I drew a picture. So if you have if you have, these two sides are going to be equal. So you have this side equal, and this side equal, and this side equal. They don't look equal, and this side equal. So as you go from 1 degree, okay. So if you go from 1 degree to 90 degrees, what happens to the area? It's going to get bigger because you're going to make this triangle bigger and bigger as you move it to bigger degrees, right? Like I did. So this triangle is going to get bigger and bigger because you're going to, these two sides are going to remain the same, but you're going to get bigger area. So the area is going to what? Increase. That one wasn't really a hard one. If you just think 1 degree, we're increasing it, and both sides are the same, then of course the area is going to get bigger. That's common sense. Number 9. So number 9 says, if the length of each side of a triangle is multiplied by 2, then the area of the triangle is multiplied by, this is another one of those, so if the length of each side of a triangle is multiplied by 2, then the area is multiplied by, so here we have area of a triangle equals 1/2 base times height. And so let's just say that we have a right triangle or whatever. We're just going to use that as an example. So we have area base times height. Well, anyway, area 1/2 base times height here. And so we end up, we're going to use it. I'm going to use a right one because then we can do base the height and we'll have to figure out that height there. But anyway, so 1/2, I just thought I put maybe one side is 1 and one side is 2. So, and then 1/2 that. So 1/2 of half of 2 is 1. So that would be one area. And then I put an area 1/2 and I multiplied it by 2. So 1 times 2 and 2 times 2 is 4. So if I multiply by 2, I have 1/2 of 8 is 4. So if I multiply it, so basically if I multiply it by 2, then I have to multiply the area by 4. 2 times 2, right? It's really similar to this one. Remember, multiply this one here with multiplying by 9 and 9 by 3, 3 times 3. So here we had to multiply. We multiply by 2, then we're not multiplying by 2, we're multiplying by the square of 2. So, because we're talking about area, so it's going to be 4. So I just made this example here. You don't have to do that, but you just think, if you have a side, you're going to multiply by the square of this number. You multiply by the square of this number is 2. It's going to be 2 times 2, right? Equal 4. So it'll be 4. The answer will be 4. This one here, the square of this number, when you're multiplying 3 times 3, that's the square of 3, because that square is then going to be multiplied by 9. So similar, those two questions, but I always did an example so I can know in my head how, if it works or not. Okay, number 10. So number 10 says, if the length of each diagonal of a square is represented by D, then the area of the square is represented by what? Okay, remember we had this before with our quiz. It says the length of the diagonal of a square is represented by D, then the area of the square. So we have the diagonal of a square equals to twice the area of the square. So you need to know that. That was on page 252. This 250 has a lot of different answers. This is number 6. Number 6. Where was it over here? Number 6. There's a check by it here. It says, prove, okay, the square on the diagonal of a square is equal to twice the area of the square. So we can use that. We won't have to sit here and try to figure it out. So here we have the diagonal of a square. So the diagonal of a number 10, kind of went up a little bit too far. So we have the diagonal of the square is equal to twice the area of the square. So the length of the diagonal square is represented by D, then the area of the square is going to be represented by what? D equals twice the square area. It's going to be this. Well, it's not going to be D. It's not going to be 2D. It's going to be 2 times the area. It's not going to be anything with a square root there, that's for sure. So it's going to be none of these. So, because it's going to be D equals 2A doesn't look like any of those answers. So that's kind of a tricky one, because you think it'd be one of them, but it's D. It's going to be twice the area of the square. So number 13. So I'm going to skip number 11 and 12 because they're constructions, and we're going to do that on your next video where we get out our compasses. So we're going to go for number 13 here. Number 13, these are figure out ones. Got to figure out the answer. So number 13 says, a diagonal of a rectangle is 10 inches and the base is 6 inches. Find the area of the rectangle. Okay, so we want to find the area of a rectangle. Area of a rectangle equals base times height. So we know only two things. We know that the base is going to be 6, but we don't know what the height is, do we? But we know that the diagonal is 10. Well, look at, we have a right triangle, so we can find that height by doing a squared plus b squared equals c squared, because it's a right triangle. So it'd be a squared plus b squared equals c squared. Okay, so let's go do our a. So we have to use our Pythagorean theorem, right? So, and a squared plus b squared equals c squared. So we have 6 squared, we put in the 6. We don't know b squared, we're looking for b, so we don't know b squared. But we know 10 squared is going to be the hypotenuse, so 10 squared. So we put this in, we have 36 plus b squared equal 100. Well, this is kind of a really neat one, because if you take 100 minus 36, you're going to get 64. So you subtract 36 here. So you have b squared equals 64. And then the square root, you can take the square root of 64 and write it out right now. We know that b is going to be 8 inches. So if b is 8 inches, well, that's our first step. So at least we know what the height is, 8 inches. So we know that this is 8, right? But they want to find the area. So now if we want to find the area, we're going to have to take the area of a rectangle is area equals the base times the height. Well, we have the height, base times the height here. We don't need that diagonal anymore. So area equals base is a 6 and height is 8. So area equals 6 times 8. 6 times 8 is going to be 48. 48 square inches is going to be your area. So the hard part was just finding with the Pythagorean theorem. So it's so nice having these theorems, and we don't have to figure like this. They had to figure those out back when, you know. So we're working on somebody else's, you know, what they have found out, like with these theorems. So on to number 14. Okay, number 14 says, the equal sides of isosceles trapezoid each measure 5 and its altitude measures 4. If the area of the trapezoid is 48, find the lengths of its bases. So we're going to have to use the formula for the trapezoid. This takes a lot of figuring, because when I first did it, I went and used an isosceles triangle, and I really missed this altogether. I forgot that it was a trapezoid, you know, which is, I just looked at it and said, oh, isosceles triangle. But now I realize, oh my goodness, that I have to do the trapezoid formula. So here we have equal sides. That means we know these sides. So I drew a picture of a trapezoid. Here's a trapezoid. It's isosceles. I mean, this is 5, this is 5. And we want to know what this base is, and we want to know what this base is, which we don't know. But we do know the altitude is 4. So we have a right triangle here and a right triangle here. So we'll be able to find this here in some way is using the right triangle. So anyway, but we have to, what is the formula for area for a triangle? First, we need to know that. So the area, or for a trapezoid, I said triangle, trapezoid. So, because this is the area of the trapezoid. The area of the trapezoid is, you get that formula, that's in your book when we're studying trapezoids, you know, I think it's section 5.5. So you have 1/2 height, and then you have to add base 1 and base 2, but we don't know base 1 and base 2. So now we want to find, to do this, we want to find what base 1 or base 2 is. Well, we can find this little number here and this little number here by using the Pythagorean theorem. So basically, I put a squared plus b squared equals c squared. And so now we can fill in a squared is going to be, we want to find out what a squared is. A squared plus 4 squared, because here we have 4 squared and equal 5 square. So a square equals 4 square equal 5 square. Filled in the C, this is the hypotenuse, and these are the two legs of the right triangle. Right there's the right triangle. So, so we have a squared plus 16 equal 25. Well, 16 taken away from 25 is 9. So we have the square root of 9. So a, we know, is going to equal 3. So I put 3, 3. This is going to be 3. But still, we don't know. We don't know what this is. This is one of our bases, and we don't know what that is. Well, so we can fill in this formula, but we have to have base 1 and base 2. Well, we know that base 1 is going to equal just base 1, but base 2 is going to be 3 plus 3, these two 3. So it's going to be base 2 is actually going to be, base 2 will equal base 1 plus 6. So we're doing one of these algebraic things, aren't we? So let's go down how to work it out. I just took this formula here, and we know the area is 48. So I filled in 48, and then we have, kind of cram this into this piece of paper, but you can follow along. So we have 48 equals 1/2. What's the height? 4, right? Times, and what are the two bases? One is just we're trying to find that base, so it's going to be base 1 plus base 1 plus 6, because this is going to be base 1 is going to be, we don't know that 9 yet, that's going to be the answer, but so we have base 1 plus base 2 is b plus 6. So we have base 1 plus b plus 6. And so then I have 48 equals 1/2 4. You know, we take a 1/2 4 times our plus 2b, because b plus b is 2b, 2b1 plus 6. So, because I just added those two together, those b's together to get them going. And so now we have 48 equals, and of course 1/2 of 4 is 2. 2 times 2b plus 6. So now I have 2 on this side, so I'm going to go ahead and get rid of this 2, and 48 divided by 2 is 24. So now I have 24 equal 2b plus 6. So now we're going up here. What is, as for 2b plus 6, we're going to subtract the 6 from the 24 and we get 18, right? So 18 equals 2b. So now we know divide it each side by 2, and we'll get 18 divided by 2 is 9 equal b. So now right away we know what one side is. We know this side is going to be 9. So if this side is 9, then what's this side going to be? 9 plus 3 plus 3, so 9 plus 6. So now we know b is going to be, we said b is equal, b2 is going to be b1 plus 6, because we're going to add those 3's on there, right? So we have b2 equals 6 plus 9, so b2 is going to be 15. So b1's 9 inches right here, and b2 is going to be 15 inches. So those are going to be the two bases, 9 plus 15 inches, or 9 and, don't put that plus there, just put 9 and 15 inches. One's going to be 9, and the other base is going to be 15 inches. So, well, the longer one. Okay, number 15. Oh, here's Hero's formula. It says, find the sides of a triangle having length 3, 4, 5. This is going to be actually an easy one to plug in. They gave you an easy one. We're not going to have a whole bunch of radicals to deal with. So anyway, so remember the two steps. Remember on page 250, number 9, that Hero's formula. So page 250, number 9, if you want to look it up. So the first part we're going to do is we're going to find the S. 2S equals A plus B plus C. So we're going to put in 2S equals 3 plus 4 plus 5. 2S equals 3 plus 4 plus 5. So 2S equals 7 plus 5 is 12. So 2S equals 12, and then we're going to divide it by the 2, get rid of that 2. And so we have S going to equal 6. So S equals 6 right there. S equals 6. You got that? Okay, now we can plug it into the big part of the formula. So we have S minus A, S minus B, S minus C. So we have A equals 6. Can't read that very good, but it's 6 times 6 minus 3, 6 minus 4, and 6 minus 5. 3, 4, and 5. So now I have 6. 6 minus 3 is 3. 6 minus 4 is 2. 6 minus 5 is 1. Kind of a weird 1 there. Hope you can read that. So now we have the square root of 6 times 3 times 2, because 1, of course, don't worry about that. So we have 6 times 6. So the square root of 6 times 6 is going to be square root of 36. What is that? We know that's going to be 6. Get rid of those 6's. So we have A equals 6 square units being our answer. So we now know the area is going to be 6. Make sure you put your square units. Whenever you have area, you got to have square units. Okay? Okay, number 16. Number 16 says, find the area of a rhombus if the diagonals are 13 and 8 inches long. Ooh, we get to use our formula again. So the area of the rhombus is 1/2 the two diagonals product. So where do we have that? Let's look at our book, see where we have that. It says the area of a rhombus equals 1/2 the product of the two diagonals. Okay, so that's the area of the rhombus. So we have two diagonals. So the area of the rhombus is 1/2 the product of their diagonals. So 13 times 8, 13 times 8. So we take, what, 13, well, I put 13 times 4 because I got rid of this, so with the 8. So basically, if you say 13 times 8 divided by 2, you're going to get 52 square inches. This is an easy one. So if you knew, you have to know this. The area of a rhombus is 1/2. Otherwise, you will not be able to get the answer very quickly. So number 17. Number 17 says, a right triangle has the hypotenuse of 17 inches and a leg of 8 inches. Find the missing leg. So, we're going to use the Pythagorean theorem because we have a right triangle. So here we have a right triangle right here. I'm going to draw it here. So there's a right triangle. And we have the hypotenuse, which is going to be 17. That's going to be C square. And leg's going to be 8. So we're going to use a squared plus b squared equals c squared. We plug it in. We don't know one of them. We'll call this a and this b and this c. So we don't know a squared. A squared plus 8 times 2 is 64 equals, this is the problem we're going to have. Now we have 17 square, So we have 17 square, which, you can get your computer and do this. It's not that hard to do. But 8 square plus, this is 64. And 17 square, if you 17 times 17, and I did it, figure this out here. This will be in your work. Just pick 17 times 17, and I figured this out, 919 is 289. So I have a squared plus 64 equal 289. So now I have to subtract the 289 from the 60 to get rid of the 64. So I have a squared equal, this is great. We know 225 is going to be an easy one because it's a square root of something. We know that. So a squared equals 225. So the square root of 225. And if you look, I found, well, it looks like it's going to be, if 17, looks like it's going to be 15 because 17 was 289, so it has to be less than 17. So I put 15, or you can just look it up, square root table or whatever. So 15 times 15 does equal 225. So the square root of 225, a is going to be 15. So it's going to be 15 inches. So that's going to be our answer, 15. This whole problem, all you had to do is use your Pythagorean theorem. You learned that back in junior high and grade school probably. A squared plus b squared equals c squared. Just plugging it in. So let's go on to number 18. So find the side of a square whose area equals a triangle with the area of 28 square inches. So this is a pretty easy one because basically we know that the area of the square is going to be 28 inches. Don't let this triangle figure get you all out of shape. You just know the areas are the equal. So the area of a square is going to be 28. So s squared equal 28. So because what? The area of a square is going to be s times base times height, or s times height, which would be s squared, right? So s squared equals 28. So s equals the square root of 28. The square root of 28, we can get that 4 out of there, right? Because 2 times 2 is 4. So 7 times 4 is 28. So it's going to be 2, or get 2. So 2 times 2 is 4. So 2 times the square root of 7 inches. That's an easy one. Don't let that try to trick you by saying, basically, you're saying, oh, the area of the triangle is 28, and then you just figure it out. Okay? On to number 19. I know this is getting a little bit long, but we only have two equations here. We'll figure out these two equations, and then we're going to do the constructions on a different one. So let's go for number 19. So number 19 says, find the area of an equilateral triangle if it has a 14-inch side. So, okay, we better draw that one. So here's an equilateral triangle, and the sides are 14, 14, and 14. So now we want to know, find the area. We need to know the height, because area equals what? Area of a triangle equals 1/2 base times height. So we need to find the height. We don't know the height here. So that's what we don't know. So we have to divide this height. We make a right triangle, then we can use our a squared times b squared equals c squared and find this height. Okay? So let's put down a squared plus b squared equals c squared. This is going to be a leg, and this is the hypotenuse, right? Because here is the right. So this is the leg, and this is the leg. So we have, this is going to be not going to be 14. This is going to be half of 14, because this altitude divides the equilateral into 2 halves. So this will be 7, and this will be 7, right? So this is going to be 7 squared plus b squared, that's the height, we don't know what it is, equals 14 squared. So 7 squared plus b squared equals 14 squared. 7 times 7 is 49 plus b squared, and you would take 14 squared on your calculator, or 14 times 14. I basically figured out, and it's 196. So I put down 49 plus b squared equal 196. Well, now let's get rid of that. Let's get rid of that 49. So I subtract the 49, I got 147. So b squared equal 147. Now what is the square root of 147? Well, we know it looks like 7s go into it. So I divided it by 7, and I got 7s go into it. 7 times 21. Okay, so 7 times 21 is 7 times 7 times 3, right? 7 times 21, here's 21. And so now I know I could get rid of these 7s. So getting rid of the 7s, I have b equals 7, this is 7, times the square root of 3, because there's still a square root of 3 left there, right? So basically have the height now is going to be 7 times the square root of 3. Okay, now we have the height, right? But we need the area. Well, we know the area is 1/2 base times height. So you fill in 1/2 base. Well, this base is going to be 14, because the side is 14. This is the base. 14 times the height, which we found up here, 7 times the square root of 3. So we fill that in. So now we have area equals 1/2 of 14 is 7, right? Times 7, here's 7, times the square root of 3. Well, 7 times 7 is 49. 49 times the square root of 3, square inches is the area. Make sure you put square inches, because we're talking about area. One more. Are we done here? This one looks hard, but it's really easy. This is one of the first ones we did on our quizzes. So it says, 2 similar polygons have the areas of 181 square inches. If a side of the first is 5, find the corresponding side. So remember, let's go way back to our theorem, our easy theorem on theorem 74. The areas of 2 similar polygons are each to each other as the square of any of the 2 corresponding sides. So basically we're going to compare the areas to the sides. So we have 100. Looks like they gave you a really good number, because you know the square roots of these numbers are going to be even. So we have right away, ooh, we're going to have to take square roots. So let that be you know, think of your mind, okay, they're giving us some numbers that have easy numbers. So 100 over 81 equals, and then we have 5 inches. This is a 5. Doesn't look like a 5. 5 inches to what number? So now we want to take, of course, it's the squares. So we have to take the square root of the areas, because the areas are the squares of the sides. So we take the square root. Just remember, this gives you a clue that they're giving you an easy number. So anyway, the square root of 100 is 10. The square root of 81 is 9 times 9 is 81, right? So 10 over 9. We can get rid of that square root. 10 over 9 equal 5 over what? This is the number we want to find out. So we can do the cross multiplying to find that number out. So 10x, 10 times x, equal 45. So 10 times x equal, get rid of the 10. So we're going to take 45 and divide it by 10. I just moved the decimal point over. We get 4.5 inches, or you can say 4.5 inches as the answer. So that one's a good one. So we look back here. Yep. So one is 5 inches, and the other is side is 4.5 inches if you're taking the areas of 100 to compared to 81. So that's going to be the quiz or the test, and we're going to go on and do the constructions in the next video.